Hi, I'm Mr. Heidowitz, and we're going to do a density column map here today. And before we begin, we need to have a good hypothesis, which our hypothesis today is what do you think will happen when we pour syrup, dish soap, water, and oil together into one graduated cylinder. Now, you need to make sure you type in your hypothesis and make sure it's a good educated guess and be specific as possible. All right? So think about this. Will they mix together? If not, which material will be separated? And if they are separate, what order do you think they'll be in?
Okay, so if you guys can, please pause the video right now and go ahead and type in your hypothesis. All right, guys, so before we actually pour these materials together, we're gonna take some measurements because once we pour them together, we're not gonna be able to do this. Okay, so as a reminder, we have mass and volume are two types of measurement that we've already learned about. Okay, the first one we're gonna look at is volume. Okay, so we already have in our graduated cylinders an amount of each material poured out. Okay, so as a reminder, when you are measuring volume using a graduated cylinder, you wanna get eye level, keeping the graduated cylinder on the table, and you want to look at the bottom of the meniscus or that curve where it curves in the middle. So Mr. Heidowitz, could you please tell me what is the volume of each material? And they're gonna be different because there's different amounts of each material in the graduated cylinders.
Sure, so we're gonna start off with the syrup. So the syrup right here, let's see. That is gonna be 10 milliliters. The dish soap is 20 milliliters. The water is 10 milliliters. And the oil is 15 milliliters.
Okay. Okay, so we can see we put our data in our chart. Okay, now we're gonna find the mass of each material. Okay, as a reminder, if we put the graduated cylinder, Mr. Heidowitz, can you put of the syrup on the scale? Okay, that's gonna give me the mass of the syrup, but it's also gonna give me the mass of the graduated cylinder. So before we take our mass, we need to take the mass of an empty graduated cylinder. Okay, what is the mass of an empty graduated cylinder?
So as you can see there, it is 5.5 grams.
Okay, so for each mass, we're gonna have to subtract 5.5 grams because we don't want the graduated cylinder being counted in our mass. Okay, so Mr. Heidowitz, if you can, find the mass of each material.
So the syrup is 20.5
Okay.
grams. The soap is 26 grams. The water is 15.5 grams. And the oil is 18.7 grams.
Okay, so as a reminder, that was our total mass. Okay, so for each one of those, we needed to subtract 5.5. So we get the syrup had a mass of 15 grams, the dish soap had a mass of 20.5, the water had a mass of 10, and the oil had a mass of 13.2 grams when we subtract the empty graduated cylinder from each. All right, so now is the fun part where we can actually see was your hypothesis correct. Okay, so we're actually going to pour the syrup, the dish soap, the water, and we actually added a drop of food dye to the water, blue, so that you'd be able to tell the difference between the water and the oil. Okay, so Mr. Heidowitz, you can go ahead, and this would work. We'd get the same results in any order. Okay.
Right, so I'm gonna start off here with the syrup, and I'm gonna take off the base so we can see a little better. So here's our syrup. I'm gonna try to add as much as possible in here. It's gonna run down the sides. Try to get as much out of this smaller graduate cylinder, the big one. We might not get all of it in there, but that's okay. We'll still be able to see what's gonna happen. All right, so that's gonna continue to run down the sides a little bit. So there's my syrup. All right, so here is the dish soap.
Okay. So you guys can kind of think, what do you think? Are they gonna mix? Is the dish soap gonna go to the bottom? Or is it going to go to the top? Okay, so remember, evidence can be observations. So we can observe here that the dish soap is actually floating on top of the syrup. So they did not mix, but instead the dish soap is floating on top of the syrup.
All right, I'm gonna change things up a little bit and I'm gonna add the oil first.
Okay. So he's adding our 15 milliliters of oil. Okay, so again, our observations, our evidence, we can observe that the oil is sitting on top of the dish soap, which is on the syrup. And our last material, the water.
Again, we added a little blue dye just to make it a little easier to tell the difference between the water and the oil because they were looking very similar. Oops.
Ooh.
Added a little too quick there, but let's see. Notice what's happening here.
Okay, so we can observe now that water went below the oil but above the dish soap. Okay, so we can see from the bottom we have syrup, then dish soap, then water, then oil. And again, guys, it didn't matter which order you do this in. Mr. Heidowitz, can you squeeze just a little bit more dish soap into the top of that?
Sure, I'll add a little bit more from the
Okay,
bottom.
just so that we can see that doesn't matter the order, that dish soap is sinking down, and it might be kind of hard to see it. Eventually, that dish soap is going to, that's good. That dish soap, you can kind of see on the end, over here on the side, is sinking down, and it's gonna sink down with the rest of the dish soap. Okay, so we can see the answer to our question, what happened. You can see if your hypothesis was correct. Should have been the syrups on the bottom, then the dish soap, then the water, then the oil, and that they all separated. Okay, in this lab, what you are gonna do with your teacher then is why did this happen? Why did the materials sort in this observed order? Okay, so we're gonna be looking at the mass, the volume, and the density to see which one of these caused this density column.